All right, so let's look at the maximum and the minimum values. This is lesson 17, and it's still about the harmonic form or the error formula. So to find the maximum and minimum values in trigonometry, it's always easier and simpler to use the error formula. So with this, they want the maximum and minimum value for this. But then we must know, we must recall that at maximum and minimum values, recall that we have this, that's equal to sine, okay, -1, sine theta, and +1. It occurs at that, then also cos theta at +1. So the maximum and minimum values occur for values of theta between -1 and 1, meaning that when you take a sine inverse of 1.5, sine inverse of 1.5, you'll get a math error, and that means that it goes beyond that. So you can get sine inverse of 1, acceptable, but a sine inverse of 1.1 will give you a math error, meaning that sine is maximum at 1, even cos is maximum at 1. A cos of 1.5 gives you a math error. So for these two, the maximum and minimum values are between -1 and +1, -1 and +1 for cos and sine. We shall be using that in our work. So now we have this one, cos theta plus sine theta, and we use the other formula. Shall now say let this one, cos theta plus sine theta equal to r. You choose what you want to let. What should we let? Okay, I prefer cos. Cos, man, when you're using cos, it should be cos theta minus. When you're using cos, if you have a plus, then you put a minus alpha. Now, our aim is to get the value of r and the value of alpha. Okay, now next we shall say a cos theta plus a sine of theta is equal to, expand to be r cos of theta cos alpha, expansion is compound angle identities, minus r, rather plus, when you expand is the plus, sine theta, a sine of alpha. Okay, good. Now from there, what you're going to do is comparing coefficients. Comparing coefficients, let me compare coefficients of cos theta. Cos theta, this side we have 1 equal to, cos theta, this side coefficient is r cos alpha, and this is inclusion, maybe 1. There. Now, coefficients of sine theta, this side we have 1 again, equals to, coefficient to the other side is r sine alpha. This is equation 2. And equation 2, what are we going to do? Equation 1 squared plus equation 2 squared will give us the answer of the value of r. So therefore, you're going to say, this will be now r squared sine squared alpha is equal to 1. Also, I'm squaring both sides, and here I've done it direct. Plus r squared cos squared alpha is equal to 1 squared. Now from there you can come and add them up. And so doing, you'll have r squared into a factorize of the r sine squared alpha plus a cos squared alpha must give us a 1 plus 1. Why 1 plus 1 is because 1 squared is 1, 1 squared is 1. Like that. Proceeding, shall I have that r squared is equal to 2. So you now come and say square root. This 2 goes out with that. So our r will be equal to root 2. That's the first case we have. Our aim is to get the value of r and the value of alpha. Next, now what we're going to do, we shall go about finding the value of alpha. And the value of alpha, what would we do? We divide equation 1 by equation 2, or equation 2 by equation 1, but we aim at creating a tan. To create tan, then this must begin. So therefore, we shall say equation 2 divided by equation 1. We aim at creating a tan. So we shall start with this. R sine alpha is equal to 1 divided by r cos alpha is also equal to 1. But we divide. The r cancels away, so we shall have tan alpha is equal to 1. And then what will you do? You say alpha is equal to a tan inverse of 1. So now our alpha will be tan inverse of 1 is just 45. Then what you will do? Bring back this science of ours. The one we rate is what we use for maximum and minimum value. So it will be now r cos theta minus alpha. So now let's put, this is a root and 2, a cos of theta minus 45. 5. The next, what are we going to do to find the maximum and minimum value? We now come this side and say, we're going to use this. We're going to use this. We say now, now we're going to use this. When sine theta is equal to 1. 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 Oh, we're having cos. Sorry, we have cos. So, shall say when cos theta is equal to 1. When cos theta is equal to 1. Now that implies, now you say when cos theta is equal to 1, that implies that here, we are going to put where there is cos, we shall put a 1. In fact, this is the edit, but here we have a different angle. So therefore, it is the same like having when cos theta minus 45 is equal to 1. That's what we mean. This one up is a demonstration. It is an edit to show you what we are meaning. But the angle here, when the angle is theta, give it a theta, but our angle is theta minus 45. So when cos theta minus 1 is equal to 45. All right. Let me write it again. So when only this one here is equal to 45. So when cos theta minus 45 degrees is equal to 1. Let's see which answer shall we get. Now first, you now come and say, you bring back this, you say, a root of 2 cos theta minus 45. Okay, like that. Now you say a root of 2. Now in the place of this, they said it is a 1. Which answer will you get? The answer you get is a positive root 2. You have that answer. Now after finding that answer there, you now come and get the angle at which it is occurring. The angle at which it is occurring. Now the angle, we get it from cos theta minus 45 is equal to 1. That's how we get the angle from. So now theta minus 45 is equal to a cos inverse of 1. Oh, did they give us the range for this? Did they give us the range for this? Oh, they gave us the range. The range in the following, the range is from 0 theta to 360. That's our range. Okay, good. So theta minus this cos inverse of that will be theta minus 45 is equal to cos inverse of 1 is 0. So cos inverse of 1 is 0 degrees, like that. But our range from 0 to 360, acceptable. 0 to 360, acceptable. Now let's see. From our circles, I'll use this area. Cos is a we have cos is a positive in this quadrant and that quadrant, and there I have theta, and here I have 360 minus theta. Now when you try to put the answers here, the answers will be that is 0, comma, and the 360, like that. Now what you do, you now come and add this to that, add this to that. So theta will be equal to a 0 plus 45, a minus, crossing the equal sign will add. Now a 0 plus 45 will give you 45, comma. The 0, a 45 plus this will give you a 3, actually 405 degrees. And you see that this one goes beyond the range. So now we have that. Now you see that here we shall have this. We have positive root 2 at 45 degrees. You can see that I have positive root 2 at 45 degrees. This answer I got after substituting for this. Then after getting the angle, you must get the function. Then where the trig function is, you put the 1. Now we have that. That's the first level. Now next also, when cos theta minus 45 is equal to 1. Now here still negative 1, sorry, because you said you test at positive 1 and you test at negative 1. Positive 1 is done. And therefore that when you substitute a 1 in the place of the trig function, you get root 2 positive at 45. Let's now see cos theta minus 45 is equal to negative 1. So you bring back to the function to be now root 2 cos theta minus 45, like that. Now you put root 2, meaning that in the place of this cos, you put a negative 1. And the answer you get will be negative root of 2. Negative root of 2. Now next, what you do, come and say from. You also come and get the angle at this level. So come and say from a cos theta minus 45 is equal to negative 1, by the way. It's equal to negative 1. So you come and say that theta minus 45 degrees is equal to a cos inverse of just 1. Right, just 1. So theta minus 45 is equal to cos inverse of 1 is as usual 0, comma. Now, which other answers shall we put there from the quadrant? We follow this one is a negative. This one is a negative, so which quadrant? Second and third. And for second, it is a 180 minus theta. Here it is 180 plus theta. So when you add that, you have okay, theta minus 45 degrees is equal to, we shall have 180 minus theta, that is 135, comma, then we shall have 180 plus theta. 180 plus theta, that is 180 plus this will be 225 degrees. Now you come and add the 45 this side. So theta will be equal to plus 45. What shall we get? This plus 45 shall get a 180, comma. Now this plus 45, what shall we get? Okay. This will give us a 270 degrees. Now I want to see which angle are we going to conclude with. So now what we do there is, we go with the first one. We go with the first one. Oh, did we get this one? This was 135. 135. Okay, 180 minus theta will be 135. 180 plus theta. 180 plus theta. This will give us right. So let's proceed. Now here, maybe another clarification you can make is here theta minus this. Oh, by the way, whenever you're dealing with maximum and minimum values, please, here you always press the inverse with that negative. Should remove this. Please, you press that inverse with the negative. Press that inverse with the negative. So cos inverse. When you're getting maximum and minimum values, parts of getting the angle, don't waste time to remove the negative. Press directly with the negative there. Cos inverse of a negative 1 will just give you 180 degrees. And with that, don't again waste time to go into the quadrants. You can leave it the way it is. Okay. Now, when you collect like terms, this will come this side. So you find that theta will be equal to 180 plus 45. So now your theta is equal to 125 degrees. Now it means that, all right. Now you compare this value here and this one. Which one is bigger? So you say this one here will be your max, and this one here will be your mean. Mean means small, max means big. So now we come and say max is root 2 at 45 degrees, and that's how I conclude, and minimum value is negative 2 at 225 degrees. As simple as that. All right, let's now go in for part B. Part B, now this is another category. I've done the other one, which is a bit linear. Then I'm doing this one, which is a fraction. And I guess with these two, shall have understood what we mean by maximum and minimum values. Now, we use our formula. So we have 2 over 3 plus 4 cos theta plus 3 sin theta. So in our solution, what you do for you let this one here, the one is with the big function, is only, let us leave them. You let that be. So now we say let 4 cos theta plus 3 sin theta equal to, please, if they have not forced you to use any, then you can opt for r cos. So r cos, okay, theta. And if you're using cos, if you have a plus, put a minus alpha, like that. So now here you start obeying your factor formula. Please, you want to pick out this part only, then you obey your factor formula. So this will be, okay, 4 cos theta plus 3, the sine of theta is equal to, expand, it will be r cos theta cos alpha plus, when you have, when expanding, when you have a minus, put a plus, r sine theta, sine alpha. Okay, comparing coefficients. The one of course, which one should I start with? Okay, let me start with the one of sine. Comparing coefficients of sine, this side you have 3 is equal to r sine alpha. That is equation 1. This side we have 4 coefficients of cos. Coefficient of cos, this side is r cos alpha. Please, here you can let anything. One can even let r sine, let this one equal to r sine theta plus alpha. You get the same answers. Okay. And after that, doing that, we need to get the value of r. How to get the value of r? You square equation 1 and equation 2. So, equation 1 squared plus equation 2 squared will give us the value of r, and that will be r squared sine squared alpha plus r squared cos squared alpha will give us, okay, you square this side plus this one squared is equal to square this plus this one squared. Okay, like that. So next, we realize that r squared is into brackets a sine squared alpha plus a cos squared alpha is equal to 9 plus 16. Now you see that a sine squared plus cos squared gives you a 1. Sine squared plus cos squared gives you a 1. So now r squared is equal to just 25. So square root of that, square root of that. So your r is just 5. Like we have it as 5. Then to get the other value of alpha, because I told you our aim is to get the value of r and the value of alpha. So to get alpha, you will say equation 1 divided by equation 2. Why are we doing that? It's because I want to create a tan. So here I will now say it will be, start with this, r sine alpha divided by r cos alpha is equal to a 3 over 4. Now the r and r cancels. We now remain with the tan alpha is equal to 3 over 4. So alpha will now be equal to a tan inverse of 3 over 4. What will now be our alpha? So shall now say 3 divided by 4 tan inverse of the answer. That is 36.1. So our alpha is equal to 36.1 degrees. Rewriting, I will bring this magic here. I will say, okay, if I have r cos theta minus alpha, but what is my r? My r is 5. The cos of theta. What is my alpha? 36.1. Now I can start with the issues of maximum and the minimum value. Okay, starting off with the issues of maximum and minimum values, shall now say, allow me to divide it into 2, like this. This side I will say, when, now you pick this guy here. Don't put the 5, you only pick it from here. The 5 you can leave it aside. The 5 you can leave it aside. You only pick this guy. You say when a cos of theta minus 36.1 is equal to 1. You will get the answers there. Then also this side, when a cos of theta minus 36.1 is equal to negative 1. These are the two categories we use. So let me deal with this first case. That will be, now you bring back this equation, you come and say, this is now a 2 over a 3 plus. Now in the place of this, remember in the place of this, you let this whole thing, which is this, to be this. Therefore, in the position of this, you put your R formula, complete value, which is this. So you come and put there the 5 cos theta minus 36.1. Please, that's what we do. Now that's in degrees. So now, but they're saying that in the place of cos theta minus 36.1, put there 1. So now you can come and say that 2 over a 3 plus a 5 brackets. The place taken over by this, you can put there 1. Now you can mathematically solve that and give us the answer there. So up we shall have a 2 over 3 plus 5 will just be 8. Okay, 2 over 8, which can be a quarter, no problem. Now after getting that value, you now come and get the angle. To get the angle, you come and say from cos theta minus 36.1 is equal to 1. Okay, so theta minus 36.1 is equal to a cos inverse of 1. So now theta minus 36.1 is equal to what? To 0. From there, sort of this will go there. So now theta, your theta will be a 36.1 degrees. Now, you can't tell which one is maximum, which one is minimum. You can't tell. We shall only tell after we have gotten each and everything. So, I have this value and I have the angle at which it is occurring. Let's now go to the other side and see how this comes about. Okay. This side we shall now say still 2 over, okay, 3 plus 5 cos theta minus 36.1. Okay. Now we come and say, okay, 2 over a 3 plus 5 into. Now, in the place of this cos, like this, you put the negative 1. So put the negative 1, like that. What will be your final answer? Be 2 over. Now, 3, this 3 minus 5. 3 minus 5 will be negative 2. Oh, and that one will just be equal to negative 1 finally. Or to be mistaken, it's negative 1. And you can see this and this one is maximum, this one is minimum. Now it is after you have substituted it. Now you can tell which one is maximum and which one is minimum. Don't always rush. Okay, back to this. Shall now say a cos of from, let's say from a cos of theta minus 36.1 is equal to negative 1. Here I told you, please, I'm pardoning again. When you're getting the inverse, just press the inverse on the calculator directly. Don't use the other usual formulas used. When you're dealing with maximum and minimum values, don't use the quadrants. So this one will be cos inverse. Put it direct as negative 1, like that. So now theta minus 36.1 will be equal to cos inverse of that will be 180 degrees. Sort of this comes this side. Theta will be equal to 180 plus 36.1 degrees. Let's add that. 180 plus 36.1 degrees will give us a 216.1. Theta is equal to 216.1 degrees. Now, we have everything. We have this value, the angle at which is occurring. Which one is maximum? Of the two, which one is maximum? It is this one. So now here, you can conclusively come and say the maximum value is, so you can say here, maximum value is, okay, it is what? Now it is a 2 over 8 at 36.1 degrees. Then also, minimum value is negative 1 occurring at a 216.1 degrees. As simple as that. All right.